Hello everyone. Today we are going to discuss on the topic TurboQuant. Now, if you try to build a PC lately, or if you are a developer trying to run a large language model locally, you have hit a brick wall. It's not just about the raw processing power anymore. It's about RAM, specifically VRAM. We are living through what experts call RAMageddon, a global bottleneck where AI demand is eating up every single stick of high bandwidth memory on the planet. But last week, Google research dropped a bombshell at the lead up to ICLR 2026. Now they call it TurboQuant. Imagine if you could take 100 GB AI model and shrink its memory footprint to just 15 GB without making it any dumber. Imagine if same model suddenly ran 8 times faster. This isn't just a small software update. This is a fundamental shift in how AI thinks and remembers. Today, we are breaking down how Google just cracked the code on AI efficiency, why your next GPU might actually be affordable again, and how this changes the war between AI giants like Google, OpenAI, and Meta. To understand TurboQuant, you first have to understand why AI is such a memory hog. When you chat with an AI like Gemini or ChatGPT, it doesn't read your prompt. It has to keep the entire conversation, the context in its short-term memory. In technical terms, we call this KV cache. Every word or token take up space. If you give an AI a 1 lakh word book to analyze, that KV cache becomes a monster. It sits in your GPU's RAM, taking a massive amount of space. This is why most AI models have limit on how much they can remember in one go. Once that RAM is full, the AI forgets the beginning of the chat or the system simply crashes with an out of memory error. For AI companies, this is a financial disaster. To serve a million users at once, they need literal hectares of H100 GPUs just to hold those memories. This is exactly why RAM prices have skyrocketed. We have been trying to solve this by quantization, basically rounding off the numbers in the AI brain to save space. But usually, when you round those numbers down too much, the AI starts losing its mind. It gets confused, hallucinated, and loses its logic. Until now. So, how does TurboQuant do it? Google used two high level mathematical tricks that sound like science fiction: PolarQuant and QJL. Let's look at PolarQuant first. Standard AI data is stored in what we call Cartesian coordinates. Think of a grid with x and y axis. To store on that grid precisely, you need two high resolution numbers. Google's researchers realized that AI data actually clusters in a very specific way. By switching to polar coordinates, storing the angle and the radius instead of x and y, they found they could represent the same data much more efficiently. It's like the difference between describing a house by its GPS coordinate versus saying it's 50 feet away at 30-degree angle. In the world of AI math, the second way is much easier to compress. But wait, there's more. When you compress data that much, you get errors. This is where QJL comes in. Quantize Johnson Linden Strauss. Think of QJL as a correction layer. It's a tiny 1 bit piece of extra information that acts like a safety net. It catches the mathematical errors caused by the compression and fixes them on the fly. Because of this, Google managed to compress AI memory down to just 3 bits per value. For context, most high-end AI uses 16 bits. We are talking about a massive reduction in size with zero loss in accuracy. Now, let's talk about the real world. Why does this matter to you and the global economy? First, the RAM shortage. The reason you can't get a cheap GPU and RAM right now because of AI companies are outbidding everyone for HBM, high bandwidth memory. They are desperate for capacity. If TurboQuant allows Google to run their models using 6x less memory, their demand for new hardware suddenly drops. If the rest of the industry adopts this, and they will, the desperation for infinite RAM starts to cool down. This could be the first step in seeing GPU prices return to earth. And the second, AI company margins. For company like OpenAI or Anthropic, the biggest cost isn't the employees, it's the electricity and the hardware. If they can save severe 6x more customers on the same server rack, their profit margin explode. This allows for cheaper subscription or even better free tiers for us. Third, the local AI revolution. This is what I am most excited about. Right now, if you want to run a powerful 70 billion parameter model locally, you need a workstation with a dual RTX 3090s or 4090s. With TurboQuant, that same model could potentially fit on a single mid-range gaming laptop. We are moving toward a world where private AI that lives on your machine and doesn't send data to the cloud, is actually powerful enough to be useful. So, what's the catch? Right now, TurboQuant is a research milestone. Google is presenting the full paper at ICLR 2026, but the code is already begun integrated into frameworks. We are likely months, not years, away from seeing this hit production. We are entering the efficiency era of AI. The last 2 years were about brute force, bigger models, more GPUs, more power. But Google has just shown that the real winner won't be the one with the most RAM, but the one who uses it smartest. TurboQuant effectively ends the context limit debate. We are looking at a future where an AI can read your entire life worth of documents and keep it aligned its head without costing a fortune. What do you think? Would you rather have a 6x faster AI, or you would use the extra memory to give your AIs forever memory? Let me know in the comments below. If you found this breakdown helpful, hit that subscribe button. We are tracking every major AI breakthrough of 2026 as they happen. This is our channel Code Z, and I will see you in the next one. Thank you.